Welcome all. Myself Shamla Devi, working as an assistant professor in the Department of Electronics and Communication Engineering at K.S.Rangasamy College of Technology. Today I am going to take about the concept on noise encountered in communication systems. So whenever we transmit information from a transmitter to a receiver, the signal never reaches in a pure form. It always gets affected by unwanted disturbances, which is known as noise. So a noise is an unwanted signal which is random in nature, which cannot be predicted exactly. Even if a system is perfectly designed, noise will still be present. For example, in television systems, noise appears as snow or grainy images. In radio systems, noise is heard as static sound. In telephone communication systems, noise causes unclear speech. And in analog communication systems, noise directly affects signal amplitude and frequency, which leads to degradation of signal quality. So, what are all the types of noise is that based on the origin of noise, it is classified into external noise and internal noise. So, whether the noise can be controlled externally, it is classified as external noise, or whether it is inherent to electronic components, it is classified as internal noise. So, we'll discuss one by one each type in detail. So, external noise is the noise that originates outside the communication systems. So these types of external noise include atmospheric noise, man-made noise, and the extraterrestrial noise. So man-made noise is that this noise is generated by electrical machines, motors, power lines, switching circuits, and household appliances. Atmospheric noise is caused by natural phenomena such as lightning, thunderstorms, and rain. It is dominant in low frequency and medium frequency radio communication systems. Extraterrestrial noise comes from sources outside the Earth, such as the Sun and other stars. It is also said to be cosmic noise. So, external noise enters the systems mainly through the antenna. So next one is internal noise. It is generated within the components of the transmitter and the receiver. So the important types of internal noise are thermal noise, short noise, flicker noise, and all. So the thermal noise, also said to be Johnson noise, is caused by the random motion of electrons due to its temperature. It exists in all resistive components and cannot be eliminated. Only it can be reduced. Short noise occurs due to the discrete nature of electric charge in semiconductor devices like diodes and transistors. Flicker noise is significant at lower frequencies and occurs in active devices. So internal noise is always present even when there is no input signal. So the sources of noise. Noise sources include both natural and artificial origins. Natural sources include lightning, solar radiation, cosmic rays and all. Artificial sources include motors, power lines and electronic circuits. So every component in a communication system contributes some amount of noise. So noise performance is a key parameter in the receiver side, for example, in the receiver design. So external noise and internal noise, as we discussed earlier. So the external noise includes atmospheric, man-made and extraterrestrial, as I told before. And then internal noises are short noise, thermal noise, transit time noise, flicker noise and partition noise. And then next one is the effects of noise. The most important effect of noise is the reduction in signal to noise ratio. So SNR is defined as the ratio of signal power to noise power. Higher SNR means the signal is of better quality. That is, it has better signal quality. So the effects of noise may include distortion of the received signal, reduction in system range, loss of information, poor quality in audio systems. So in FM systems, frequency modulation systems, noise causes a threshold effect where below a certain SNR, signal quality suddenly degrades. So how to minimize these? So since noise cannot be completely removed, we have to mitigate it. That is, we have to reduce it. So noise mitigation aims to improve SNR, reduce noise bandwidth, minimize noise generation within the circuits itself. So some common techniques include using low noise amplifiers, increasing transmitted signal power, selecting noise resistant modulation techniques and all. So mainly using techniques and all the mitigation methods which we all use is that first one is the filtering technique. So filtering is one of the most fundamental and effective techniques used to reduce noise in communication systems. So the basic idea behind filtering method is that it allows the desired signal frequencies to pass and attenuate unwanted noise frequencies. So, since noise is completely eliminated here, the we can simply eliminate noise over a wide range of frequencies, so which helps in improving signal to noise ratio. So type of filtering methods include, we can also use low pass filtering, high pass filtering, band pass filtering, band stop or notch filtering, and then matched filtering methods and all we can use. So the next one is the uh, modulation strategies also we can use. Modulation plays a very important role in reducing the effect of noise in communication systems. So the basic idea behind modulation is that to shift the signal from low frequency to high frequency where noise interference is very less and transmission becomes efficient. So different modulation techniques respond differently to noise. So by choosing a proper modulation strategy, we can significantly improve the SNR of the signal. Out of amplitude modulation AM, frequency modulation FM, and phase modulation PM techniques, FM and PM is of much better noise immunity when compared to AM systems. And then next one is by proper receiver system design, we can also reduce the effects of noise here. So on the whole, we can use the filtering methods and all, and then proper modulation strategies, and then by using the proper system designs we can reduce noise. So noise is an unavoidable and inherent part of all communication systems. So even though in modern communication systems noise cannot be completely eliminated, it can only be controlled and minimized. We have seen before, noise originates from both external sources like atmospheric man-made and disturbances, and internal sources like thermal short and flicker within electronic components. So these noise sources degrade the SNR. So we have seen filtering methods which reduce, and the modulation strategies and proper design strategies to reduce noise. So even though when we are using these techniques, we can only be able to minimize and reduce the noise level, but we cannot completely eliminate it, since noise can be originated from both the external and the internal sources as we seen before, but we can reduce it by using a proper design techniques. So when we conclude, successful communication system design depends on the ability to maximize SNR and ensure signal reception in the presence of noise. A thorough understanding of noise characteristic and control techniques offers high quality communication system design. So when we are designing a communication system, we have to be keep it in mind. So, listen to the concepts which I have explained and try to answer these questions. Thank you all.